Hi, I'm Veronica Belmont. Technology has been a passion of mine since I was young, and now I'm helping a new generation of kids discover their own passion for the world of STEM: science, technology, engineering, and mathematics. From amazing architects to NASA's most exciting engineers. Let's meet some of the people who are creating the future and redefining what's possible for all of us. Welcome back, I'm Veronica Belmont, and on this episode of the Meristem Project, we're tackling something big, really big, like squash your house like a bug big. That's right, we're talking about dinosaurs. But we're not only going to talk about how big they were, where they lived, when they lived, or what they ate. What we're going to talk about today is just how can we know so much about these amazing creatures that haven't been seen on Earth for 165 million years. In finding the answer to that question, we're going to go on a journey, not only through time, but across the planet, down through layers of Earth and deep into the heart of an amazing fossil lab at the University of Chicago. And our guide for that journey, my friend, paleontologist Lisa Zago. Her friends call her Dino Girl. Lisa has loved dinosaurs her entire life. That's why she studied paleontology and why she spends her days digging for that next great fossil in exotic locations, prepping fossils for study in the lab, and thankfully for us, sharing that love of paleontology with school children through her work with Dinosauria. So in just a moment, we're going to go meet Lisa in her lab. Let's go! So Lisa, these are some incredible specimens you have here at the lab.
Sure are. These are over 65 million years old. These are beautiful artist interpretations of what the animals may have looked like in the past. We have everything from pancake croc to Nigersaurus here.
This is a really amazing place. How does someone get here, working as a paleontologist, dealing with fossils that are 65 million years, 250 million years old? It's pretty incredible.
Oh, I've loved dinosaurs since I was a small child, and it's never really left me. I started my work in the field, attending lectures, following lab activities, and eventually started my own program for children about the age of dinosaurs, and hopefully encouraging them to someday investigate the past, become paleontologists, and contribute to the fossil record.
Now, just to get it from the paleontologist's mouth, what is paleontology and what exactly does a paleontologist do?
Paleontology is the study of life, the history of life. So a lot of times what we're doing is we're piecing together the fossil record. A lot of times it falls into two different categories. You can be a geologist, you can be a biologist. With geologist, obviously it's a good part to understand the layers of the Earth and the history of the Earth to find fossils, to be able to discuss what may have happened. Biologists are very good at the anatomy and putting things together as they were.
Is paleontology always about dinosaurs?
No, it's not always about dinosaurs. I think that's a common misconception. A lot of people think paleontologists are dinosaur people. A lot of paleontologists are fish people, or they may be studying something else, plants or botany. Dinosaur science is just one area. Paleontology is a very broad field.
And so what do paleontologists actually do?
So if a paleontologist is in the field, they're working with generally a hammer, chisel, a brush all day long, maybe hiking or searching for fossils. If you're in a lab, you may be preparing things or investigating, putting together the pieces of the puzzle. You may be putting together maps from the field and sort of piecing skeletons back together from what was found in situ in the field.
All right, Lisa, let's see how many dinosaurs you can name in 15 seconds. Are you ready?
15 seconds, ready?
And go.
Okay, Allosaurus, Camptosaurus, Apatosaurus, Stegosaurus, Camarasaurus, Triceratops, T-Rex, Parasaurolophus, Pachycephalosaurus, Troodon, Deinonychus.
Out of time! Oh, that was great. All right, so clearly you know a lot of different dinosaurs. Do you have a personal favorite, and why?
I do. I have a lot of personal favorites, but one that's coming to mind now is Dracorex hogwartsia. And this animal is absolutely amazing. And what I like about this dinosaur is the skull. It's this very compact skull that it looks like a dragon, and it's got all of these horns and points popping out all over the place. That's probably my favorite one.
And I assume a Harry Potter fan named it?
Absolutely.
Yeah. Every minute, trillions of tiny atomic particles called neutrinos are passing through your body. And most of those were created billions of years before dinosaurs roamed the Earth. It's like we're learning something new about dinosaurs every single day. We learn so much from these fossils, but how and where do we find them?
Dinosaurs are found all over the world on every single continent. So when we're looking at dinosaurs, we're looking at the Mesozoic era. You might start with a geological map and start to break down which layers are exposed and which periods we're looking at. You might start with the Cretaceous, which is the youngest, the Jurassic is in the middle, and then we have the Triassic being the oldest.
So now that we can tell how old fossils are based on where we find them in the Earth, how can we use these fossils to learn more about these dinosaurs? For example, if they ate meat, or if they ate plants, or even if they could fly.
Well, it's important to understand that a lot of times when we find a dinosaur in the ground, we're not finding a complete, well-articulated skeleton with a skull attached to it. Many times we're finding just parts and pieces that are not associated to each other. So for instance, if you're lucky enough to find a tooth, something with a nice curve to it with a serration, we know we're talking about a meat eater. If we have something that's more spatulate-like with some ridges or grooves in it, we're talking about a plant eater.
And if it's a creature that can fly, do we see the wings? Do we see the feathers on the wings? Or can we just tell based on the shape of the bones as well?
A lot of times you can see that these are thinner, longer bones. That's an indication immediately that you have something that may be flying. But a lot of that stuff is early, it's Cretaceous, so it's much younger than a lot of these Jurassic or Triassic dinosaurs. And it's sort of rare to come across it. They're so thin. Same thing with skull parts. A lot of times this stuff isn't going to fossilize. It's like paper plate thin, and it's just going to vanish, and the conditions wouldn't be right for it to fossilize.
Today, paleontologists are replacing a lot of their fossil picks and brushes with technology like MRI, magnetic resonance imaging, and X-rays. Okay, now we have some questions from our home STEMers. Do you think you can help them out?
I would love to answer their questions.
If you only have bones, how do you know what dinosaurs look like with muscle and skin?
So we only have dinosaur bones to look at. Well, how we get the skin would be with skin impressions. Luckily, we have several mummies. These are hadrosaurs. We have duck-billed dinosaurs that show us textures on the surface of the skin. To flesh out a dinosaur, we also use living animals as a model. Scientists are constantly doing calculations to figure out the mass of the body of a dinosaur. One of the most important things I would love to mention would be the imagination. It's very interesting and exciting to come up with colors and different imprints and patterns on the skin, just using your imagination.
My friends say that birds are actually dinosaurs. Is that really true?
Birds and dinosaurs are similar in many ways. They both have feathers, pneumatic skeletons. There are some of the same nesting techniques that they used. Also, there's evidence of smooth stones called gastroliths that were aiding in digestion in the skeletons that have been found of dinosaurs, as we also know that this is a common behavior in modern birds.
So if someone out there wants to become a paleontologist, what do they need to do?
I recommend studying geology or biology. Those are the two disciplines that really work along with paleontology. We use geology, study of the rocks, to hunt fossils, and then biology to piece things together for the fossil record. Doesn't have to be that you've got a PhD though. You can also work in the field collecting fossils or researching. Museums have plenty of fossil prep labs where people can do work there. There's also artist jobs available, photography, things like that.
Thanks again, Lisa Zago, for this amazing tour. If people want to learn more about you or your work, where should they go?
To learn more about my work with kids in paleontology, you can go to dinosaurhunter.net.
I love that website address. That is awesome. And a huge thanks to the University of Chicago for letting us into the lab to see all the amazing work they are doing here. Stay tuned. When we come back, we're going over the answers to last episode's challenge. See you back in 120,000 milliseconds. The newly discovered wonder material, graphene, is so strong, a sheet of it as thin as cellophane could support a T-Rex standing on a pencil without tearing. All right, Meristemers, last week we gave you a math challenge. If you remember, it went a little something like this. Tara and Lauren are going to play a spinner game. These are the rules. When it's a player's turn, you spin both spinners. add the two numbers that the spinner points to. If the sum is odd, Tara wins, even if it's not her turn. If the sum is even, Lauren wins, even if it's not her turn. Now, both girls think that they have a better chance of winning. Is either right? We asked you to send us your answer along with why you think you're right. And this week's winner, chosen at random from all of the correct answers, was Olivia, 10 years old from Rockford, Illinois. Olivia wrote, well, they have the same chance. There are 4 possible outcomes from any set of spins. Even, even odd, odd odd, odd even. When you add them up, 2 end up even and 2 end up odd. So they're both equally likely to win. Great job, Olivia, that's exactly right. We'll be sending you out a Meristem Project t-shirt right away. If you could put any 23 dinosaurs, or your classmates, in a room, there is a 50% probability 2 of them share a birthday. Okay, now it's time for this week's challenge. It's a science question and it is a doozy. Ready? And to present that challenge, let's go back to Lisa Zago, aka Dino Girl.
If you were to drill a tunnel straight through the entire Earth, straight from where you are through the exact center and out the opposite side, and then jump down into this tunnel, how would you fall?
Remember, submit your entries on Facebook, via Twitter to @Veronica, that's me, or on our website, meristemproject.com. That's it for this episode. I hope you enjoyed meeting Dino Girl Lisa Zago. If you want to learn more about paleontology or being a paleontologist, you might like these books. National Geographic Kids' Ultimate Dinopedia, the most complete dinosaur reference ever, or The Dinosaur Museum, an unforgettable interactive virtual tour through dinosaur history. Or I really like the PaleoCast podcast. They have some 40 hours of amazing audio free to download. Or if you like videos, try the History Channel's Dinosaur Secrets Revealed, National Geographic's Awesome Sky Monsters, or Nova's Arctic Dinosaurs. We'll have links to these and other reference materials, complete show notes, an archive of challenge questions and answers, plus a ton of other STEM stuff on our site, meristemproject.com. So until next time, keep learning, keep exploring, and always keep growing.